Yeah, dear students, let us move to the second part of this material management. So, in the previous lecture, we have covered the concept of material management, we have covered inventory, and we have briefed what do you mean by inventory control. In this present lecture, we will discuss on the methods of inventory control. There are two methods through which you can do inventory control. They are economic order quantity, and the second one is ABC analysis. What do you mean by this economic order quantity? Let us discuss this in detail. It is also known as economic lot size. So, the control of inventory is a two-step decision process. So, there are two questions need to be asked. For any decision to happen, we are supposed to ask several questions on to ourselves. Regarding this economic order quantity, we are supposed to ask two questions which is of most importance. So, it is regards to the inventory that we are going to deal with. So, in this, the two questions that we generally ask is, the first one is how much to buy. So, this decision is generally based on the costs involved in the purchase, and the second important question is that when to buy it, whether to buy it now or just wait to buy the commodities. So there are obviously high risk on this second choice, because if you wait to buy the stock, there will be a risk of stock out. It means to say that when you intend to buy something, probably there will not be much amount of inventory stock available. So hence the entire process will be standstill. And in other case, if you buy additional materials for granted, probably what happens is you will be having the cost of holding the extra inventory. That means to storing you have to find or you have to keep aside some amount for the same. So there are obviously two risks on when to buy that question, for that question. Now let us slowly discuss on each of this. So first one is how much to buy. So here the most obvious thing or concept that we consider is the cost involved in buying the commodity. So let us see some of the cost that is involved in the inventory purchases or inventories. The first one is said to be the ordering cost. That means the additional cost of placing an order or reorder. When you order something, it will be coming in the form of a lots. So whenever you order something, it will not be, it will be in the number of orders that you place and not the size of an order. The order may be sufficiently big enough. So if that is the case, in one order you will finish off the thing. But at the same time, if you have number of orders, probably the cost involved will be different. So that type of cost is said to be the ordering cost. The second type of cost is nothing but the setup cost. The setup cost is nothing but while you set up a system, probably you may have to stop the production over there. So that is again it is independent of the quantity to be produced. How much you are going to produce, it's immaterial, but while you set up it, probably the production has to be standstill. So under that situation, that type of cost is said to be the setup cost, and the setup time is the total time required to prepare a machine for production or to prepare a system to be ready enough to start production. So that generally consists of machine. This is generally on machine setups or the mechanical workshops types. This is generally set to. So it is having a setup cost, namely the machine downtime cost, cost of idle wages, loss of profit, etc. Now Apart from this, we have another type of cost. Earlier also we have discussed holding cost or carrying cost. So when this cost is nothing but when an inventory of sufficient volume, irrespective of the orders, when it is kept in position or in ready, it is for a prolonged period of time, we have something known as this carrying cost or holding cost. So that increases with the volume of the inventory, and it is irrespective of the number of orders. So normally this is linearly related with the quantum, the amount of the inventory. So normally, in normal cases, the cost of carrying inventory is expressed in annual percentage of the unit purchase cost. How much purchase you are making, unit purchase you are making, that purchase cost, of which a certain percentage, annual percentage, we will keep aside as the total cost of carrying inventory. So normally that value is considered to be 25%, and the breakup of this 25% is as follows. The first one is obviously your obsolescence, that is 10%, interest in inventory investment payment is 6%, physical deterioration and prevention cost is 5%, distribution, handling, transportation 3%, tax, insurance, rent for storage is 1%. That's how you get this 25%. Now, how to decide how much to buy? You have something known as, if there is a comparative study that you are supposed to do. So of the cost, the ordering cost and carrying cost need to be considered the most. So if the smaller the quantity is chosen, if the quantity amount or the quantity is chosen is very small, the purchase orders are frequent. You have to purchase it most frequently, and hence the number of orders would be high. So in that case, your ordering cost will be higher and the carrying cost would be lower order, because you are utilizing the material so fast, so that you want to order it most frequently and you don't keep it idle in your place, so the carrying cost would be lesser for this case. But if the quantity that you have chosen is larger, you will be having only less purchase orders. So at a moment you will get larger amount of inventories. So in that case, your ordering cost would be a normal value, that is a low value, but at the same time you will be having a carrying cost which is of a higher value, because you are keeping those materials ready at your place for your further use. Now here what you are supposed to do is, the question is of balancing these two opposite costs. When one thing is high, the other one would be low. When the other one is high, this would be low. So in this case, you have to balance these two opposite costs and determine the optimum quantity that you require. This is nothing but the basics of your economic order quantity. So you have to balance the situation, as well as you have to have only a minimum overall cost. So that is the basics of your economic order quantity. So under which conditions this EOQ concept applies? So EOQ concept applies in a situation wherein you will be replenishing the lots or batches. It means every time you order the materials then and there, and that cases you will be having this EOQ concepts can be applied. Either by purchasing or manufacturing, you are continuously replenishing the lots, and it is not produced continuously. This the materials gets consumed in a particular intervals only. So it's not a continuous process throughout, it is not going, but it's the product that is coming out is continuous, but the materials that is going inside, that is you are giving it in a separate intervals, that's all. So it's not a continuously that you are inputting into it. And sales or usage rates are uniform and are low compared to the rate at which the item is normally produced. So sales, that when how much you are selling or how much you are using is uniform, irrespective, or low, and are low compared to the rate at which the item is normally produced, so that the significant amount of inventory results. So you will be having sufficient number of inventories within you. And this is not applicable to the products where you have limited tool life, short shelf life, and economical use of raw materials and similar other constraints. So these are the conditions under which EOQ can be applied, and there are conditions under which EOQ cannot be applied. Now, there are different techniques for finding this economic order quantity, out of which we have three major techniques. The first one is mathematical approach, the second one is tabular approach, and the third one is graphical approach. This second and third one we will just go through in a glance, that's all. But mathematical approach we will go in detail, because similar types of questions have been asked for the university exams also. So let us see what is this mathematical approach. This mathematical approach, we have EOQ is the quantity whose procurement cost is equal to the inventory carrying cost. So you are balancing how much you procure, that cost is equal to the inventory carrying cost. So keeping this in mind, it is a balanced product. So we all know that the quantity whose total cost, when you take, it is nothing but ordering or procurement cost plus the carrying cost, and this entire cost has to be kept minimum. That is what is mentioned over here. The total whose the quantity whose total cost, that means the ordering cost or the procurement cost plus the carrying cost, is a minimum. That is nothing but that quantity is nothing but your economic order quantity. So here let us see some of the terminologies in which the total cost is said to be TC, ordering cost plus carrying cost, and certain terms that we are coming across is D, it is demand rate, that is how much units per year. Ordering cost, how much rupees per order, that is generally termed as A. C is the unit cost, how much rupees per unit of the item. And inventory carrying charges, that is we have already discussed, it is per year we are calculating, annual year we are calculating. Then H is annual cost of carrying inventory per unit item. H is nothing but your inventory carrying cost that we have discussed already. And Q is nothing but order quantity. That means this is what we are going to find out. It is number of units per lot. So total number of orders placed, how much orders that you are placing, depends upon what is this D per Q every year. That is nothing but total demand rate divided by the order quantity, that is for every year. So the ordering cost or procuring cost per year will be equal to the number of orders placed per year into the cost per order. So that means number of ordering cost is A into the number of orders placed, that is D by Q. So that is how we get this A into D by Q. Now here we can see this diagram is very peculiar diagram, in which you can see that this is the inventory level in the y-axis, and the x-axis have your time in days. So you can find that, let us say you have this much amount of inventories within you, and you will find that as it gets consumed, the materials gets consumed, you find that it is coming down. So as the time passes, the level of inventory is coming down, and at this point we again recharge it or replenish your order, so you will get your total inventory level to go like this. So this is how the process continues. If the demand is at a uniform rate, the average inventory required would be equal to Q by 2. That is your Q by 2 that you are going to have. Now let us see the next one, the inventory carrying or holding cost, which is expressed as the percentage of unit price of an item. So inventory carrying cost per year is equal to how much order quantity is there into cost of item into the annual cost to carry. So that means it is nothing but C into I into Q. Order quantity is Q, unit cost per item into annual cost to carry divided by 2. So that means Ci is nothing but your H into Q by 2. So where H is equal to C into I. Now you can see that the total cost TC is equal to ordering cost plus carrying cost. You have TC is equal to AD by Q, which we have ordering cost we have calculated in the earlier slide, we have seen it, and then we have seen that carrying cost is equal to HQ by 2. So for optimum Q, we need to find the particular value of Q which will have minimum total cost. So how to get it? The DC by DQ should be equal to 0. So upon calculating, you get the total ordering or the economic order quantity Q is equal to root of 2 into order cost into demand divided by the inventory carrying cost, which is nothing but Q is equal to root of 2AD divided by IC. This expression is very much important to find out the economic order quantity or the quantity of the order Q. So what are the major assumptions in applying this EOQ model? So you can see that the demand is deterministic. We can find out how much is the demand, and it is continuous, and the consumption rate is very constant. Under these conditions, we can apply this EOQ model very effectively. And you all know that basic information on price per unit, ordering cost, carrying cost, etc. is available and is fairly accurate. If any one of this rate is lump sum, we cannot find the actual EOQ. Then the process continues infinitely. This process is a continuous process. There is no change in the process. So in that case also you can apply this. No constraints are imposed on quantities ordered, storage capacity, budget, etc. And replenishment is instantaneous. You would have noticed that in that figure, all of a sudden it is getting replenished, continuous vertical line upward. So that is why this replenished is very instantaneous, and all costs are time invariant. There is no dependent on it is not dependent on time, and no shortage of items is there, and you have very negligible or deterministic lead time. Lead time we will discuss in detail later. And unit price rate is constant irrespective of the quantity purchased. In many of the cases you would have noticed that if the quantities are more, there will be some relaxation in the unit prices. So that is a variant case that we are supposed to follow. In normal cases, we just consider it to be having a unit price rate, and it is constant irrespective of the quantities that you purchase, and all order quantity arrives at one time. There is no half delivering right now and later on you will do the next partial shipment of your material. That is not possible. All quantities, all order should arrive to the required position at a time. So these are the general assumptions that we apply on EOQ model. So this is a tabular approach we have already discussed. In the tabular approach, we have to select the number of possible lot or order sizes, determine the total cost of each lot size chosen, and then select the ordering quantity that minimizes the total cost. So this is the tabular approach, which is not so significant for your case. And the graphical approach, this you should know what it is, in which you can see that you have a holding cost like this, which is a variant. We have already discussed it is linear, and you have a setup cost or order or cost curve is there, and this is the cost for both total cost of holding as well as setup. So this curve is very much important. So you should choose a minimum cost over here, and then you have to take the optimum order. So this is nothing but a graphical approach. So normally it is applicable for manufactured items. It is a simple mechanical workshop that we have obviously discussed before, but this is also applicable in construction sites also. And you can see that variants of typical pattern of EOQ. You can have different variants. This whatever we have discussed till now is a general pattern. You can have more sophisticated variants also along with it. The variants could be of the type quantity discounts you can give, that is by means of cost comparison approach or price break approach. You can avail quantity discounts, and then deviations of purchase of lot sizes from theoretical EOQ is possible, and EOQ model with stock outs allowed is also possible. So these are the certain types of variants that is applicable for the typical patterns of EOQ. So this is you can just go through these 3-4 slides, in which for your knowledge interest you can have this, but it is not so important as far as your examination point of view is concerned, but you can just go through it for improving your understanding. So this is about your price break approach and discount of lot sizes from theoretical EOQ by stockouts if it is allowed, because in our general assumptions we are not supposed to have your stockouts, but if you consider stockouts, this is the way how you can include that variant into your EOQ model. Now we are coming to the next question that we are supposed to ask. It is nothing but when to buy, or what is the order point. So once the decision of how much to buy is made, then next is when to buy it. So that is very important. We have already found out the quantity Q earlier from the earlier discussion. Now we have to decide when to buy it. So we should obviously understand there will be available or virtual stock, quantity in hand plus quantity on order minus demand on hand yet to be complied. So this is very important. We have whatever quantities in hand that we have, quantity on order you will get, and demand also you have to consider, and it is to be compared and with a certain level of stock called order point to see whether it is time to buy. So you have to fix something known as an order point. Let us discuss that in detail from this figure. You would have noticed that here it's the inventory value as we have discussed from the previous figure, and this is your time scale in which you can see that this much amount is available as EOQ. This is your order quantity that we have already discussed, EOQ. Now as the EOQ comes down, you can see that at a particular interval you are supposed to order your materials. Now you can see that this much quantity is kept as a safety stock. So you cannot utilize that material as such because it is very difficult. You will have to shut down your system if you utilize these stock, and even after the stock, if the material is not arrived to the site, probably you have to shut down your system. In order to avoid that, we will keep this as a buffer value. We have to order at this point, and with the consumption of materials till this time. So this time is said to be your lead time. We have mentioned this lead time before. So at this point we will order. As the material gets finished off till this point, you will get your order replenished to this much. So this process continues. So this line is your order point wherein you are supposed to place your order, and it should not go below this safety stock. So this is the order point that we are supposed to see. So this lead time is dependent on many factors. We are supposed to keep many of these factors into consideration while you have your calculating your lead time. That means what is the time required for your stockist to supply your materials, to do your pre-tender work, tender processing time is required, delivery period is required, transportation time, receipt and inspection of item, time taken for handing over the material. So to have this lead time, we should consider all these 7 factors to fix out this lead time concept. Okay, so once you accept the good, it will replenish your inventory. So that is what it is. So accordingly, we are supposed to have your order point. So how to have this selective inventory control? We have something known as inventory control policies. The name of the policies is mentioned over here. Some of the items will be VED type, that is nothing but vital, essential, desirable. So you have this materials is so critical, so it is very much required in your site. So in that condition we have to adopt this VED. Now FSN is nothing but fast, slow, normal. That means if your materials are getting consumed, so that leads to your FSN model. And HML is nothing but high, medium, low. That means it depends upon the price of the material, unit price of the material. You can have high, medium, low type of policy. And here it is SDE, it is the difficulty in procurement, that is scarce, difficult, easy to obtain. So these are the conditions on which you have your SIC, inventory control, and these are the policies that we follow in the inventory control. So next discussion we will go on to the ABC analysis. Thank you.